Nesting data. We've previously learned two main data structures for holding multiple pieces of data in one place. Lists hold data of the same type, while data classes make new types that can hold different kinds of data. Up until now, we've only put primitive data into our lists and data classes. But now we will start mixing those data types. The chapter begins with one of the most useful and common combinations, lists of data classes. In the example shown here, we have a list of picture instances. Each element of the list is a picture, and each picture has the same type of attributes. Each picture has distinct values, though, allowing us to represent many complicated things in one place. A comparable idea is a table or spreadsheet. Much of this chapter is dedicated to showing how we can process this kind of data using the loop patterns we have already seen. Data classes can be placed not only in lists, but also in other data classes. We've actually already seen this with Designer's World data classes, which had designer objects inside. But now we will make our own data classes with other data classes inside. Composing data classes allows us to isolate chunks of data into smaller pieces that are easier to think about. We can also reuse those new data classes in more than one place. Nesting data classes requires chaining together multiple attribute accesses, which can feel a little strange at first. In some ways, nesting lists inside of each other is simpler than nesting data classes, since lists are a more built-in type. However, dealing with nested for loops can be quite tricky. The example code shown here also incorporates an enumerate, which is not necessary unless you want access to the indexes as well. Critically, note how we first iterate through each row and then each number inside of that row. Also demonstrated here is indexing a specific element, which requires chaining together two indexes. There's no end to how much we can nest data classes and lists together. By doing so, we can represent truly complex data. Of course, this also requires more nesting of control structures and attribute accesses. Just like with the other combinations of data structures, all of the same rules apply. It's all just a matter of keeping the data clear in your mind.